In this video we're going to be looking at completing the square, and that's where we factorise an expression or an equation into an expression like this. And these bits of information, the A and the B, tell us information about the turning point of the graph. So whether we have a positive quadratic or a negative quadratic, it'll tell us the exact coordinates of that turning point, and we'll look at how that works with the following examples. So for the first one, we have x squared plus 8x. So how this works is we have to half this term here, so we'll have x plus 4 all squared, and then we'll need to take away the number, because if we were to expand this bracket here, x plus 4 times x plus 4, we would get x squared plus 8x, which is what we want, but we would also get plus 16 when we multiply these two together. So for our answer we need to minus 16. So what we're saying is that this expression here is the same as this one here, because if we expand this we get those two terms plus 16, so we need to take away 16 to make it 0. So we'll have this expression. Now let's do the same for the next one. This one's different because we're going to have a fraction in our A term here. So we'll have x, and then we half the coefficient, so it'll just be plus a half all squared, and then take away this number squared. That number squared is a quarter, so we're going to subtract a quarter. So if we look at the next one, this one again is different because this time we've got a coefficient of x squared, and for this to work we need to factorise out that coefficient. So I'm going to factorise out 3, I'm going to put the whole thing in square brackets, and we're going to be left with x squared plus 4x. And now we can complete the square on this expression here. So again, keeping the square brackets, we'll have x plus 2 all squared, and then 2 squared is 4, so we need to take away that 4. And we're not finished yet. What we need to do now is to multiply out the square bracket. So we're going to multiply both terms by 3, so we're going to do 3 times this and 3 times that. So this first term is just going to be 3x plus 2 squared, and then 3 times minus 4 is minus 12. Now let's have a look at how this applies to the graph. If we look at the first one, this here, it's a positive quadratic because this is a positive coefficient. So we know that it's going to have a shape like this. Now this point on the graph, this turning point, is the lowest point on the y-axis of the graph. So if we had y equals 3x plus 2 squared minus 12, which is essentially our function, but we've completed the square on it, we can see that this point is the lowest on the y-axis. So when will this be the lowest point? So we're doing a number, take away a 12. So for this number to be as low as possible, this needs to be as low as possible, and the lowest that a square number can possibly be is 0. So we're going to have to make this inside here 0. So to find the coordinates of that point, the x coordinate is going to be when x plus 2 equals 0, so that'll be x is minus 2, and the y coordinate is going to be when this part is equal to 0, so y will be 12. So our coordinate here is when x is minus 2 and y is minus 12. So we found the coordinates of the turning point. We'll have a look at another example like that later in the video when there's a negative quadratic. So if we look at this next one, the fourth one, again it's a tricky example. This time we have to factorise out again. So we'll have take the 2 out, and that'll leave us with x squared and then plus 9 over 2x. So it's easier when we leave these as fractions. And then we're going to complete the square on those two terms. So again, square brackets, but this will have x and then half on this term here. So x plus half of 9 over 2 is going to be 9 over 4x, and that's, sorry, not x, 9 over 4, and then all squared. And then we need to take away 9 over 4 squared, so 9 times 9 is 81, and 4 times 4 is 16, so that's that one. And we need to multiply out by 2, so we'll have 2 times x plus 9 over 4 all squared, and then multiplying this one by 2 will give us 81 over 8. And if I was to do the coordinates, the x coordinate is where this bracket equals 0, so that would be when x is minus 9 over 4, so we've got minus 9 over 4, that's the coordinates of our turning point here, and the y coordinate is minus 81 over 8. So those are our two coordinates, or our coordinates for this turning point here. Okay, moving on to the last two examples. So this one here, if you notice on all the previous examples we had a positive sign in between them. The next one doesn't, and it doesn't change it at all really, but I wanted to show you an example with one anyway. It's quite a complex one. So if I take out the 4, I'm going to have the square bracket, so we'll have x plus minus 10 over 4, which simplifies to 5 over 2 x, so that's x squared, and then complete the square, so we'll have 4, we'll have x minus half of 5 over 2 is 5 over 4 all squared, and then subtract 5 over 4 squared is going to be 25 over 16, and then multiply out by 4, so we'll have 4 times x minus 5 over 4 all squared minus 25 over 4. And then again our x coordinates for this one, it's again a positive because there's a positive coefficient of x squared. So the turning point is going to be when this bracket is 0, so x would have to, x minus 5 over 4 equals 0, which means that x is 5 over 4. So 5 over 4, and the y coordinate is minus 25 over 4. The final one is a negative quadratic, which is going to look like this. And we're going to find this coordinate here by completing the square. We find the coordinate of the turning point. So the method's the same. We're going to remove the minus 2 by factorising, which will leave us with x squared minus 2x. Then we're going to complete the square on those two terms inside the brackets, so we'll have minus 2 and then x minus 1 all squared, and then 1 times 1 is 1, so we need to subtract 1. Then we need to multiply through by minus 2, so we'll get minus 2 x minus 1 squared, and then that'll be plus 2. That's our completing the square, that's done. But now to find the turning point, if I just rearrange this, it'll be 2 minus 2 times x minus 1 squared. So to find the turning point, we need to find the highest possible value that y could be. So if we had this as y equals the function, we'd have a graph then, and then we're doing 2 minus a number. So to make this as big as possible, this needs to be as small as it could possibly be, because we don't want to take off anything. If we took off something, this would become smaller. So we would find out to make this whole thing 0, we need to make this bracket here 0. So it's going to be x minus 1 is 0. So x is 1. So that's our coordinate, our x coordinate. And if that is 0, then y is going to be 2. So our coordinates there are 1, 2. So we've been able to find the coordinates of the turning point using completing the square.